Hello, my name's Roman. I'm from Turbonomic, and I'm going to be talking about, a brokerless REST interface for gRPC services. I have a bit of a cough, so you may hear that throughout the presentation, but just bear with me. So the agenda is a little bit long, but each point is pretty quick. I'm basically just going to go over how we got to the point where we needed to come up with this solution, and then what we did. As a quick spoiler alert, what we did was we wrote a Protobuf compiler plugin and like a little mini framework for them to generate Spring Web REST controllers that we inject into the application. If that makes 100% sense, then then you may not have a lot more surprises in this presentation, but then I'll just go into more detail about why we had to do it and how it works. So before I get into the actual work that we did, I'll just spend a few minutes talking about who we are, and we, I mean Turbonomic. Basically, we're a company that automates your workloads in a hybrid cloud environment, which basically means you have your applications running on your VMs or on containers or on any other technology, and we basically match the demand of the application to the supply of the infrastructure. That's kind of the marketing spin on things, and I'll just quickly go over what that actually looks like in practice. So suppose this cloud here is your hybrid cloud environment, and in this environment you have a vSphere instance, so vCenter, a bunch of hosts, and the hosts have VMs, and you also have an AWS account, and you have some VMs running in there, and occasionally you want to move VMs from vSphere over to AWS. You want to resize them as the demands of your applications change, and you want to size them down later. And you want to know, when you need more hosts, or when you can power off some hosts, or when, when it's more cost efficient to use the AWS environment or the vSphere environment. And doing that all by hand is like a giant headache, because you have to manually connect to vSphere and AWS, tweak a bunch of controls, and it in a large scale environment that's just really difficult for a single person or even a group of people to do well. What we do is we have an application that you deploy inside your environment, and the application does that for you. So it connects to vSphere, connects to AWS, connects to all the other types of platforms, and then it basically manages it for you. And of course, there should be an arrow over here because we have like a UI and API, and you can talk to it. But really, the vision is that it'll manage and optimize your data center. So, you might think that sounds like a neat idea, and some other people thought so too. So we got some customers, and as we got bigger customers, we had to deal with larger environments in that application. As you see over here, we have, this little application here, and it it used to be a single Java, Tomcat thing, and that worked well for, let's say, 10,000 entities, but when we want to go from 10,000 entities to 50,000 entities to 100,000 entities, it proved to not be quite good enough. And we're thinking, well, what can we do to have greater scalability? And what we decided to do was, independently scalable containerized components, also kind of known as microservices. So this is what our microservices architecture ended up looking like. So you, over here on the left side, you have your vSphere and your AWS again, and those are just logical boxes containing the whole environment. And inside we have a component, I'm talking like logical component, the mediation component, which connects to those, to all the platforms that we support using their externally available APIs. And it combines the various data models into a single abstraction that kind of fits the whole environment. That abstraction then goes out to all these other components that have their own functionality. So for example, we have the analysis engine, and that's the one that drives, I was talking about matching supply to demand. That's the one that drives all those and tells you what actions you need to take to, improve the health of your environment. Then you have history, which, keeps stats and that sort of thing. You have policy, which you can use to define certain policies, like, for example, these two VMs should always be in the same cluster, or things like that. And then those components will be accessible via an external API, which includes a UI component, and the user that we talked about earlier is over there making, either making REST calls or clicking around in the UI. And that's kind of how the whole thing works. And there's more components, down here. But even with this many, you can see there's a lot of green arrows, and all the green arrows are some form of communication. So in the first iteration of this architecture, we had two types of communication. The first type was pub/sub with Protobuf. You're in a gRPC talk, so I assume you know what Protobuf is. But basically, it's a like binary serialization, messaging format published by Google and so on. And then we had synchronous calls with Java interfaces hiding Spring REST. Yes, we are a Java shop, so all our code is in Java, as will, and the demo and the samples I'm going to show later are also going to be in Java. So, and this is what that looked like. You have, suppose you have an echo component, which, just has some really simple functionality. You pass in a string and it returns the string. So we'd have an interface that looks something like this, and the clients would create an instance, an implementing class of that interface, and then on the component, in the echo component, you'd have the echo controller. And this is using all the Spring annotations like REST controller, request mapping, all that stuff. This API operation here is Swagger documentation. It's just annotations that'll provide that you can scan to generate documentation for your REST API. And that'll become important in the next point. So, that worked fine for our purposes, but it had a couple of problems. And actually the biggest problem for us was that developers had to do a lot of work to get this, create this illusion of RPCs. One of the reasons for that is because, as I mentioned earlier, we were using Protobuf messages for pub/sub. And then we had to create in-between Java objects to kind of work with those Protobuf messages, because we wanted to have like a nice and documented REST API, and using Protobuf over REST with the documentation and annotations and all of that. It was a big pain. So basically, every time you create a new interface, you'd have to, create the relevant objects, write the two Protobuf and from Protobuf methods, and add the, going back to that illusion, add the illusion of the, the method and all the kind of plumbing to get that to work. And it was a big pain. And we're basically manually implementing a RPC layer on top of REST. There were libraries that we evaluated as far as helping us with that. And actually gRPC was an alternative approach. And then another thing was performance. Now, at the time that we made this decision to switch over to gRPC, performance, and namely speed, wasn't really a big concern, because our major data flows are going over pub/sub, which isn't really affected by this. But as we kind of progressed, looking at some of the messages and the amount of data that goes between components now, it's a good thing that we did this, because getting the extra speed benefit, is really nice. So kind of after evaluating a few things, we basically ended up trying to go for gRPC as the solution to our problems. This is what that echo service might look like in gRPC. I'm not going to do like a long introduction, but just a quick refresher. So you have your service. It has an RPC. which has a request message and returns a response message. The request message contains a string. The response message contains a string. And then, yes, and then on the server, you implement that service. Here it's just, sending the next response to the observer and completing the call. And on the client, you create a stub, and you use the stub to make a call, almost like it's a local call, but not quite. So that worked well, and it didn't take long to get started with, and teaching everyone how to use gRPC and design gRPC services wasn't that bad. But we still ran into a particular problem, and it kind of circled back to developer productivity again, because what happened over the time that we were using REST was we kind of got used to all the tooling that's available for REST, and not just like the developers would use the REST calls using like curl or Swagger UI or Postman to debug the containers to see what targets are defined, what actions are being recommended, and so on. And this was just when gRPC Java and gRPC in general 1.0 was being released, and there wasn't a lot of equivalent tools to do that in the gRPC realm. There was gRPC Gateway, which you may be familiar with, but it's basically it's a similar thing. It generates basically a proxy that you can kind of start up, and then the proxy will you can direct your HTTP request to the proxy, and then it'll make gRPC calls to your service. But then that it required a proxy, and it also required us to add add it to our whole tool chain, and it's a bunch of Go code, and then getting it to build. Well, basically, we decided that it wasn't ideal, and we would want something that's more embedded into our application. And our solution, spoiler alert again, is to create a Protobuf compiler that would generate these controllers, and that could, and then to embed, those generated controllers into our Spring application context. And that would look something like this. So going back to our echo service, you have the echo request, you have the echo response, we went over that. And then after you kind of push it through this plugin, it would generate a much more convoluted looking controller. Well, this is kind of an excerpt because it's a bunch of code. But you see here, it's echo, and it returns the echo response and takes in an echo request. This is the default version. And then, well, one noteworthy thing is, the documentation gets copied into this API operation as well, so that when you generate documentation for it, if you want to, you'll have that as well. Now I'll just do a quick demo of what that actually looks like. Exit this real quick. Okay. Okay. This is a live demo, so we'll see how that works. So here, I don't know if can people see? I'll zoom in a little bit. Zoom in here. I don't know how to zoom in. Okay, sorry. Yeah, so here you have like a simple application. This is a slightly more fancy echo service. Here you can actually create echo objects which have this string as a content, and that's just to illustrate some additional features. And it's pretty straightforward. There's a get, create, update, and delete, and this is the implementation of that service. It's just backed by a hash map, and all the calls kind of do what you expect. I did put in an error here. If you're trying to create one with an ID that already exists, it'll throw an error. And then this is the application. It's a Spring Boot application. We create this gRPC server here. We add the echo service, and this docket here, it's for the Swagger documentation, which you'll see in a bit. So let me pull this over here as well. So then, So we'll just build this real quick, and then hopefully it works. Okay, and then we'll run it. And after we run it, we can go to the Swagger UI, which is just like a UI on top of the REST API, and you see there's nothing there because this is without any without the plugin. And the problem that we were hitting at this point initially was, okay, well, now that we have this, we know the service is running, and we can connect other components to it. But what if I want to see if echo 5 exists or what it is? Well, there's no really easy way to do that. So going back to, I'll shut this down. Check out the master branch. So here you'll see this is actually completely unchanged, the application itself. The service is also unchanged. You'll see that, oh, oops. Damn it. It's hard to twist my neck around. Okay. You'll see that here we added some annotations to customize the way we'd want these routes to be presented. So, the get echo would just be like get/echo/ID. Create echo would be like a post. And there's two alternate ways. One is to post the content to /echo/ID, and another one is to just post to /echo with this create echo request, which contains an ID and a content, and so on. And another thing is we add this to the configuration of the Protobuf Maven plugin, which is what we use in Java to generate Protobuf out of the proto files. And this is the Proto-Gen Spring REST plugin. So now, going back to here, do a build. Should be fairly quick. We'll run it again. Okay. All right. So now it's running, and now you can see there is an echo service controller here. So we can go over here and we can say, okay, well, let's try creating a new echo, and we'll say so content. Let's say hello, and the ID should be 7. And let's try it out. So it returned successfully. The body of the response is this. So that means that if we do can I close this? Yeah. If we do a get echo, get echo 7, we should get the same thing. So yeah, we got this echo that we just created. And well, I mean, I can illustrate delete and all that. I guess I'll do delete. But yeah, then after that, we'll say, okay, we don't need it anymore. Goodbye. And then so that's successful, it returned the same thing. And now if we try this out, we'll see, there's nothing here. Well, by default, it doesn't throw an error right now. It just returns unset instance. And then just as a thing with when we're talking about errors, so suppose I create the thing with 7. The first time it works. The second time I create it, it says, oh, it's an error. There's a duplicate ID. And that's because of that error that we defined earlier. So that's kind of the gist of it. There's the HTTP rule that we're using. It's like the common Google annotation. It has a bunch more features, but yeah, I'm not going to demonstrate all of them here. So that's kind of the gist of the demo. And now I'll spend the next maybe 5 minutes or so talking about how it works. So the way it works is the same way any Protobuf compiler works, compiler plugin. The Protobuf compiler, when you run it, you pass it the list of plugins, which is what we're doing in that Maven configuration there. And then the compiler will write serialized code generator request protos to standard in, and your plugin is responsible for reading those. And it looks something like this. There is a request. It has one file descriptor proto for each file. And the way that our echo service would map to them is something like this. So the service would be, in the service descriptor protos. The messages would be in the descriptor protos. Inside descriptor protos, there is, representations for fields and for methods and all that stuff. So we read that in, and then for each file, we parse the descriptors and we create Java objects out of them. And then once we, in the Java objects, this is just a snapshot from the IDE, but the Java objects, just contain some helper methods to get information about the, about the field. So for example, the echo request would be represented by a message descriptor, and then there would be a list of field descriptors that you can get from it, and that's where you'd find a field descriptor for the echo field. So once we've parsed the descriptors into Java objects, we make calls to the specific generator to actually generate some code using those descriptors. So it's not actually an interface, but this is like the, in brackets, framework part of this, that we actually have several plugins that use the same template. Each plugin just implements these methods, and then the main framework kind of makes the calls into them. So generate message code, service code, enum code, the imports and all that other stuff. And then once you've generated, once you do that, you're generating the code. So this is going back to the service method. Here we have response entity. This was echo request. This was echo. This was echo response, and so on. So we just here is just using string templates. You could do whatever you want potentially. And then we write a code generator response to standard out. And that just looks like this. So, there's a list of files, and each file has, a string, and the string is just the code, and the code gets written to the file. That's kind of it. If you want to take a look at it to see how it works in detail, you can take a look at the common framework over here, and the REST plugin itself is over here. There's a, we did implement this mostly for ourselves, for our QA department, and there's, definitely a lot of work that could be done to make it 100%, production ready. And yeah, so if there's interest, like I'm spending some time working on it, and it would be cool if other people did as well. And if you want to learn more about us and what we do, we have a booth, so you can come talk to us there as well. So that's all. And if anyone has any questions, you can. Yeah. So the question is, how do we handle streaming? So this is where that part about it not being 100% production quality comes in. The way we do it right now is we just, let's say if your input is a client stream, then the relevant REST input would just be like a JSON array. And if your output is a server stream, then it would be a JSON array of the response objects. Yeah. I don't know about cloud endpoints. Oh, so the question was if I know about cloud endpoints and how it compares. Yeah, so I can't answer that directly. If you can give me like a one-sentence summary, I could.
It's basically API management. any gRPC.
That's interesting. Yeah, I'll check that out. Yeah, I don't want to make assumptions about what it is based on our 2-minute talk. So, but yeah, that sounds pretty cool. Right. Well, yeah. If you guys have more questions, we can talk after. But otherwise, I think we're good. Thank you.